those monitors. All right, so we're here in Visual C++ world again, and today we have Martyn Lovell. So who are you? What do you do?
Hi, my name is Martyn Lovell. I'm a development lead on the C++ libraries team, and I work on the technologies of MFC and ATL, the C runtime libraries, plus I work a lot on the managed code solutions the C++ team has done in the last few years.
Okay. So with the advent of managed code and C#, VB.NET, etc., so MFC is evolving?
That's right.
I remember hearing that it wasn't going to evolve anymore.
Well, MFC has a long history of being downplayed and then upplayed again. And what we hear when we talk to our customers is that most of the C++ customers have some MFC usage in their organizations. And in fact, that MFC still has a large following. And when we think about moving customers from the Windows XP to Windows Vista platforms, we feel like there's a lot of benefit we can get by providing Windows Vista features in the MFC libraries. For example, in our last version, we help people who want to use the .NET framework and an MFC at the same time by providing WinForms integration into MFC. So even MFC and ATL, which are quite historic technologies, some of them founded 15, 20 years ago, are still undergoing significant change inside VC.
Outstanding. So I have to ask, before we go any further, do you actually use all these monitors?
I really do. I have two monitors that I use for my email and my collaboration. These two monitors are connected to my development machine, so I use this for coding. And then this monitor is connected to another development machine that I'm just bringing up and booting up, so eventually this machine will take over these two monitors, and then I won't have a fifth monitor, because I don't really like having 5 monitors. 4 is really kind of my conceptual limit.
Excellent.
I was a tester for the Multimon team back in 1997 when we did Multimon for Windows 98, and I got hooked on Multimon. My home system is Multimon. I'm just obsessed with it at this point.
So Multimon is the multi-monitor.
Yeah. Windows
now, could you have a multi-monitor set up with 5?
You can actually. Windows lets you go. There's a site on the internet somewhere where you can see pictures of people who have 9 monitor setups and all sorts of things. So you can do a really large number of monitors. My personal limit is I kind of want it to be in my line of sight, so I feel like 2 or 3 is my limit. So, and I like these big 21-inch monitors, so I feel like 2 or 3 is about the max.
Excellent. So can we turn those off behind you, because we have a little interference patterns going?
Yes.
Or just the monitors? Yeah, that's fine. Just a little interference patterns we have.
That's probably just my hair.
So specifically, what you're working on is this thing called Secure CRT.
That's right.
Can you talk about that?
Yeah. In Visual Studio 2005, we added the Secure Libraries initiative to the whole of our VC product line. And the Secure Libraries are improved versions of our C runtime libraries, of our C++ libraries, MFC and ATL, that provide better safety. Now, as with any security feature, no feature can be a silver bullet and solve all your security problems. But what we found was there are simple things we can do that will take existing code and with no changes make it more safe, and further things we can do where we can easily recognize a place where you've done something risky and suggest a recommended replacement with something safer that you can do instead. And this all came out of work we've been doing over the last 5 or 6 years inside Microsoft. You may have noticed there's a little bit of security attention to Microsoft recently, and that led us to do a lot of security reviews of the Windows code, of the Office code, of all the code across Microsoft, and we learned certain functions were unsafe. We learned that certain coding practices were unsafe. And the very first thing that happened was in Microsoft, we ended up with tools that said, I'll look for this unsafe thing and tell you when you did this unsafe thing as an internal tool just for Microsoft. But what we did with Visual Studio 2005 is we said, we want to share those tools with the community. We want to share our best practices so that you, if you want to secure your code, can do so in exactly the same way we do, by getting a warning when you do something unsafe and by being given advice on how to do that more safely. And the Secure Libraries lets us do that effectively.
Fantastic. Very cool.
It's nice because when I first took over this team about 5 years ago, we had the situation where what we were recommending to customers, if you looked at our docs would say, strcpy. Here's a function that lets you copy a string. Whereas if you went to talk to Michael Howard about strcpy, Michael Howard would say, strcpy, evil, never use. But there was this massive disconnect between what our public documentation was saying and what our internal development practice and advice was saying.
Sure.
And what we did with VS 2005 is we took all that advice, all that learning, all the things we did to make sure our code bases internally were better, and exposed them out to the community. So that now you can tell when someone has done something unsafe and give them some safe advice instead, and that happens automatically at compile time, so you know what you're doing.
Cool. So this is built into the compiler, or it's
part of the libraries, but so that makes it automatically happen at compile time, effectively. So there's actually also a related feature that is built into the compiler that works very closely with this, called /analyze. It's the analyze switch on the compiler, which does static analysis and looks for bugs in your functions and suggests ways in which your functions might cause crashes or cause problems. And this static analysis feature works closely together with the secure libraries to make sure that when you write unsafe code, we find it and we can recommend things to do. And when you write unsafe code that's too complex to be found by the libraries, the static analysis tool, which takes a bit longer to run, can find much deeper problems in your code.
Absolutely.
So it's a very neat family of features, and it means that we are now in the position where the advice we give to internal people is very closely synced to what advice we give to external people, and we've given the technologies we have to help internal people write safe code to external people as well.
That's great.
And that's really great.
Especially for C++, which is an inherently unsafe language.
Well, the thing we think about in C++ is that you can write very safe, very secure, very well-organized C++ code, but you can also write very dangerous things. C++ is like a very sharp knife, and it can be used very, very well. If you write modern C++, if you use classes for your strings, if you use exceptions, if you use modern C++ programming techniques, you can write very, very safe code right there. And with 2005, you can also write code running on .NET and C++ that's even got the security of the managed runtime. However, a lot of people have C++ code that was written in 1983. The earliest comment in my personal code base, the code that I own at Microsoft, is a comment from 1983 that has a date on it. And so that's somewhere in the CRT. And there is very old code hanging around in a lot of companies. A lot of the code that exists in Windows and Office, parts of it were written 10, 15, 20 years ago. And that code was written before we understood how to write the best C++. It was written before we understood how to do the most things. In fact, it was written before C++ even existed in lots of cases, because the C++ language really only came into common usage 15 years ago, and before that a lot of C code has been up-converted to C++, but is really just C code. So taking that code and making it safe was our mission. We know that if you rewrite code from scratch in C++, you can write very safe code, and you don't need the help we're giving you here, because you can write that code just using standard libraries and standard techniques. But if you have that legacy C code and that legacy C++ code that's really mostly C code that uses printf and strcpy and all those 25, 30-year-old APIs from Unix and POSIX and the C standard, then getting that code safe is much more challenging and requires some techniques that we think we've learned how to do at Microsoft and that we're sharing here.
Excellent. So what is it about C++ besides pointers, for example, that gives you this super sharp knife?
Well, let me show you an example of something on the whiteboard.
Let's do it.
Okay, this is a canonical example of how we have a problem. So say we have a buffer for characters that's 10 bytes big, and then we'd say strcpy dest. This is a completely safe piece of code. We have a destination buffer of 10 bytes, and we're copying this string hello into this destination buffer. The string is only 6 bytes long. Everything's fine. However, let's say we now make this value 4. I've now converted this code from totally safe code into a buffer overrun, the most evil and scary thing that we have in the world. And there's no compiler feature before now that would ever warn or tell you that anything is wrong with this code. All that you're going to see is a successful compilation, and in fact, if you're lucky, this code might even run successfully, because in practice, maybe this buffer overrun won't hit anything bad, and maybe everything will just work out fine. If there's nothing else in this program, this code might actually run successfully too, which is even more scary. So the sharp knife gives you the ability to be wrong and the ability to be right. What we feel is that strcpy is simply too dangerous a sharp knife to use. And so for our iteration of the libraries, you get a compiler warning from this. You get a C4996, which basically is telling you, we think this function is dangerous and you probably shouldn't be using it, because it just doesn't know. You pass this function this pointer, but you never tell the function that the size is 4. So how is this function going to know that it can't fit this whole string in there? It doesn't have enough information to be safe. Strcpy, it just can't behave safely. It can only rely on you to give it safe information. So strcpy relies on you to be smart. And clearly I am a very smart person. I never write any bugs in my code, but other people very occasionally write bugs in their code. So, I just have to protect against that. So when you get this warning, it will also tell you that there's a better function called strcpy_s. And for the CRT function, this _s pattern is the standard pattern. So my handwriting is kind of bad, but anyway.
And that just basically means safe.
Yes.
Or safer.
Safer is exactly the right way to think about it. So then you would change your code to this, strcpy_s, dest, and then say for, or even better, you could put in, I don't have the space for it, _count of dest, and that will get us the value for, and then hello, and then this code will then be able to, at runtime, say, hey, I've got a 4 size, this is bigger than 4, I'm going to abort the program because I would have buffer overrun, and that's dangerous. And simultaneously, because the code now explicitly states its assumptions, that this is as big as this, and then the static analysis code we have can detect when you make a mistake here. Say you're kind of crazy and you write ×2 because you think you have some Unicode thing going on, or you're in some way clever. You write this ×2, and that's wrong because this buffer is only 4. Our static analysis has the opportunity to detect that case and report a warning that this size isn't right. So by making the assumptions of the code explicit, these functions allow you to automatically detect at compile time and detect when you've done something wrong at runtime. So you get that double protection.
Okay.
A further improvement that we have, if this is really C++, and you've written this, then we have a compiler switch you can throw that will automatically convert this at compile time into a strcpy_s dest 4, because we use clever template tricks that exist only in C++, one of the reasons we like C++, to automatically transform this unsafe call into a safe call, because we really know this is a 4 size buffer, so we really know everything we need to know here. The compiler knows enough, and we can use template magic to detect that case and correctly call the right function. But we can only do that in C++. If this is straight C code, there's no cleverness in C that's clever enough to catch that up. But for C++, we can do that.
So now what about the dynamic allocation of size?
So you're imagining the case where
you don't know that as the programmer.
Yeah, so you've done equals malloc, whatever, something, some value that was passed in. So then you have to make sure that the function you're working on knows what size buffer it's dealing with so that it can pass it on to strcpy. And that's just good practice anyway. Your function should never be dealing with an output buffer whose size it doesn't know. One of the things we found when we looked at the Windows API and the C APIs is there's a few functions in Windows and a few functions in the C library that don't know the size of their output buffers, which means those functions can never behave safely. Strcpy is such a function, getHas is such a function. There are Windows messages that have this behavior, and in general we've gone through the Win32 API and we've gone through the C libraries and all those things and created safe versions of those functions so we can be sure that every function that's working with an output buffer knows how big it is, so it knows where it can write to and where it can't write to effectively.
Excellent. Perfect. And you just, as you mentioned, you put that switch on the compiler and it'll automatically use the safer versions.
That's right. It's a pound define. I can't remember. It's a long name, pound define, but it's documented, and it'll automatically substitute safe versions where it can.
Cool.
Now, for a lot of our libraries are not C libraries, but C++ libraries.
Okay.
So, for example, if you have a std : string in C++, which is a nice string class that works well, you don't have to make any change to this code to make it safe. The changes we made in the libraries and the design of the C++ standard library are so good that we only needed to add extra checking inside our own code, and this code is automatically checked. You don't need to do anything to your code. So really, it's only at the C library level that you have to change your code. For the other kinds of libraries, the libraries are well designed, either in this case by the standards committee or ATL and MFC are generally well put together, and so we can just silently be safe inside our own code with almost no change to your code. And that makes for a much cleaner upgrade experience, but when you've used these older APIs, there's nothing we can do. We have to advise you to upgrade your code effectively.
Absolutely. Well, that's excellent. And your tools help with that.
Yes,
with
that's
that
right.
Advising. So you think many people are still writing C code besides the operating system type developers or driver developers? I mean,
so there is. So I actually participate in the C Standards Committee, and I know from being there that there is a significant set of people who are really writing C code.
Okay.
Even on the Microsoft platform, we see a significant number of developers writing C code. But I would say those people are outnumbered by the people who are really writing C++ code, but have pockets of C-style coding in their C++. They use classes, they have objects, they have all the C++ stuff, but somewhere in a function, they have a piece of code that takes a buffer, does a strict copy, does a printf, and so on. And we find this all across Windows and SQL, and we've applied all these secure libraries all to the Microsoft technologies, and even the pieces of the code base that are pretty C++-centric occasionally have bits of C code. And the older the code is, the more, someone got an image processing routine from someone else in the company that was written in C, or they upgraded some old code and they added some C++ code. So there's mixtures of kinds of code. And so you do end up with code that is mixtures of C-style coding in C++ with proper C++-style coding. You then get the really, really up-to-date people who are doing proper C++ coding only. And those people are in the best position safety-wise in our experience. If you're always using string classes, you're never allowed to use buffers. If you're always using exceptions to process your errors, if you're always doing checking and so on, you can write very secure code in C++ without any of this help required. But even so, the changes we've made to the libraries will make sure that we're double-checking that you've done the right thing. So we even improved your safety a little bit, but not nearly as much as we've helped the people who have the older, more legacy code.
So that which sort of begs the question. Is there a penalty that you pay for writing, for not using buffers? So are these? I mean,
that's a really great question. I mean, the performance penalty. A traditional reason people choose C and C++ is performance. And as a team, we spend a lot of effort focusing on making the performance of our code strong. Anytime you add an error check or a buffer check, you're adding some number of instructions that get executed, so there is some hypothetical penalty to those things. But in modern systems, often instruction count and instruction execution is not the only factor in making the performance of an application. The performance of a disk system bringing code into memory, and the performance of paging, and the performance of output to the video card, and many other things factors into performance. So for most cases where we have actually changed these secure functions, we've not had a measurable impact on performance tests that are being run that measure real customer scenarios. Now, that doesn't mean we haven't seen impact cases. If you take a tight algorithm that's doing something really central and it's doing a lot of data processing and it's not doing anything else, you can end up with cases where the perf impact here is visible at least. Although in the cases we have seen, it's very rarely significant.
Sure.
Now, what we did find for the C++ library, because it has high flexibility, is there were some cases that were difficult to optimize completely, and we didn't get all those optimized in Visual Studio 2005. But for all the common cases, we got performance feedback from our customers during our beta testing and fixed those performance issues and got things sped up. I think that we've added a bunch of safety and security features in our compiler and our libraries and so on over the last few versions, and we've generally eaten only a few percentage of performance in doing that. But there's always more work we can be doing on performance. It's always easy to sound complacent about this and say, oh yeah, we always have processor power to spare because, thank goodness for AMD and Intel, they keep making things faster and, but in practice, we're also really laser focused in VC on making sure we have good performing code. There's people in our team who spend all their time running spec and running other benchmarks and making sure that the abstraction penalties stay low and the libraries stay efficient. And if people find performance problems with the libraries, I really encourage them to go to the MSDN Product Feedback Center and send us bugs. Every bug you enter on the MSDN Product Feedback Center gets seen by me back 15 minutes later when I look at my bug query, and we see those bugs and we respond to them, and generally we can either help you find the source of your performance problem, and maybe there's a different compiler switch or a different default that's hit you. We've seen a few of those. Or maybe we found a real bug in our product. Just yesterday, I was working with someone who works with me who was working with a customer, and the customer had reported a performance problem, and the customer actually already had a workaround and had a bug in that workaround. And we were helping them with a bug in the workaround, But also, we looked at the performance problem that had made the customer look for the workaround to start with. We found the performance problem. We think we have a fix for it. We're going to try and get that into our next service pack. So anytime you bring something to our attention, whether it's a feature bug or a performance bug, we're going to try and make those fixes, because that interaction we get directly with customers about bugs is one of the most valuable things that goes on here. It's one of the nicest changes of Microsoft over the last 10 years. I mean, really, these direct connection bug databases really let us directly deal with customers. I'm so excited every time a customer sends me a bug. Because I'm obviously depressed that we have a bug in our code, and that's bad. But really, we found out about that bug. I can't tell you how many times in the past, say 7 or 8 years ago, I would go to a conference and meet someone who'd say, there's a bug in your product. I reported it 3 times. No one did anything. Nothing happened. And now I can tell people, go to the product feedback center. Every time you report on the bug in the libraries, I will personally read that bug. I read every single bug that goes through there. That means our team responds to those bugs directly. And that means they get into our priorities. Our division is prioritizing those bugs from that feedback center higher than any other kind of bug. So we are using that channel back to customers in a really, really productive way. And I personally love that, because we can finally say with confidence, we're fixing the bugs customers are telling us about, instead of them getting lost in some email thread or lost in some bureaucratic chain or somewhere like that. They're really getting through it to us, and that's really great. I'm really excited.
And I mean, and the fact is that customers are directly involved with the evolution of the product, or in terms of quality. And
that's right.
I mean, they could also go to the MSDN Product Feedback Center and provide a suggestion.
That's right. And those suggestions I was just on a trip to Berlin for the C Standards Committee, and in Berlin I didn't have much else to do. I've been to Berlin before. It's a lovely city, but I spent some of my evenings reading the several hundred customer suggestion bugs that have come in over the last 2 or 3 years, because we're right in the middle of planning the next version of our product, and I wanted to make sure that I had in my head all the kinds of things people were asking about, so we could bucketize them and work out which things went with other things, but also just so that I could get a feel for these bugs. So I started out with a query of 900 things. I subsetted some things that I had already read recently, already kind of knew about, and I ended up rereading about 500 customer reported and other internally reported issues, and that's having that database of stuff that came straight from the feedback center and straight from other things is tremendously useful, and getting that direct customer feedback often teaches us things we don't know about our own products. I might say to someone, I don't think anyone ever does that, and then I search our bug database and find someone who's doing it, and that's a lesson. So it's incredibly valuable, that connection we get.
Excellent. So let's talk a little bit about the evolution of C++. I mean, we're at, what is this, version 8 now? Or is how do you reply?
It's kind of amusing how you think of versioning, because we're back around to version 8 all over again. We got C up to version 7, and then we went to Visual C 1. So really this is compiler version 14, I think, or maybe 15. So yeah, C++ has been going at Microsoft for some considerable time. We haven't been shipping it as often as we would like to. We're trying to get our shipments to happen slightly more often by being more efficient internally. But C++ is very much moving forward. We're trying to pursue a dual strategy. We're the only product that really compiles basically the same code we compiled 10 years ago. We still have all that native code generation, all the same libraries we basically had, all the same scenarios basically supported. But also we have this whole new language in C++/CLI, a whole language extension set targeted at the CLI platform. And so we try and provide a bridge between the old and the new, but we try not to think about the old as the old. From our perspective, keeping native code vibrant, keeping Win32 development vibrant, keeping it easy to write a straight native app with no managed code on the Windows platform is just as important to us as it is to provide a really great bridge between that native platform and that managed platform. We're trying to make sure that customers who have investments in millions of lines of C++ source code have rational paths to bring that code forward into new generations and to evolve it forward to new operating systems without a big rewrite, without a big change. Clearly, some customers want to do that rewrite. Some customers want to move to a C# or to VB.NET or to some new language and rewrite their code. And we think C++/CLI is a great language to choose for your rewrite, but we cover both bases.
Now, some of the feedback I do hear out in the development community is that the syntax of C++ versus a language like C# has led some people to want to go to C#, so they don't. It's a much easier language to program in, unless you're already a C++ expert. So there's that sort of complexity that you have to deal with. C++ isn't going anywhere. I mean, that's what I'm saying. I mean, it's evolving, right? But managed code is in the forefront right now, as far as typically language. C++ is higher level programming than C, right? Higher level than assembler, blah blah blah. So languages keep getting farther and farther away from what's really going on under the covers. And then, of course, there's a penalty for that, et cetera, et cetera. So that's what I meant by the evolution of C++, just trying to get the message out that and you said it perfectly, that you're evolving in parallel with the managed world.
Right.
And you're providing excellent bridges.
Right.
Do you ever foresee a time where there'll be significant syntactic change in C++?
There's some really exciting stuff going on in the C++ Standards Committee, and in the C++ community as a whole. Lots of evolutionary stuff is happening. I am not as closely tied into the language changes as I am to the library changes, but there are some really interesting new abstractions coming into C++. There's something called concepts that Bjarne and a bunch of other people on the Standards Committee have been working on to improve the way metaprogramming can work. So metaprogramming is this notion in C++ that you can write a function that works for any type. So you don't just write a function that can take the square root of an integer and a different function takes the square root of a floating point number. You can write a templatized function that takes a square root of any type in some way, if you work out how to do that. So metaprogramming is that notion of programming the programming language. And C++ is adding much more powerful tools for metaprogramming in terms of concepts and other features that really actually raise the abstraction bar above what you can get today in C#, for example. So I don't think C++ is falling behind in terms of what it offers in terms of improved abstraction and improved language. Now, you're right that because C++ chooses to be syntax compatible with C, essentially, and because it chooses to be a language that preserves investments, it can get pretty syntactically hairy. I mean, there are corners of the C++ syntax and semantics that challenge all but the best of us to understand and remember and internalize. And you'll notice that one of the things I have on my desk is the C language guide, C++ language guide, the C standard, the C++ standard, and the POSIX standard, all sitting there in the pile.
Sure.
Because essentially one of the things I'm most commonly doing as I'm looking at bugs and I'm looking at features is thinking, what does the standard say about that? What does the standard say about this? So with those differing features, we are still improving C++. We're still improving that language. I don't think there'll be any time where we'll probably drop all of the syntactic legacy of C, but already there are moves to drop some of the most annoying corner cases that come out of C and moves to improve the syntax that we have for the cases that are common. Plus, I think what happens when teams work in C++ long term is that they learn the subset of the syntax and subset of the features that their whole team is comfortable with, and with good code reviewing and good coding practices, you end up with something that isn't dramatically more complex to work with, in my personal experience, in C#. And C# is great. I think those languages do fill a niche for a certain kind of programming.
Yep.
But I do think that you can really program almost as simply in C++ as C#, assuming you are restricting yourself to a set of practices and set of habits that work simply and consistently.
Certainly.
And that's a challenge for initially setting up a team, but once you set that up, you can really build very large amounts of safe and good code that way. So,
do you ever foresee a time where there'll be no pointers in C++?
That's a really interesting question. I think this question of how runtime environments are going to evolve in the next 15 years is really open in my mind. I mean, I think there are some people who really feel like we're going to go to a completely object-based runtime system, where something like the CLR or the Java runtime will underlie everything, where one day device drivers will be written in managed code, or one day everything will be written in managed code. I guess my experience is that is not likely to happen for a very long time. It seems to me that from talking to ISVs and from talking to customers, there are a whole bunch of situations where the abstractions that exist in C++ are probably still going to remain important. But I think the big difference is that even though those abstractions are going to be there, we're going to see less and less code that uses strip copy, that uses the traditional C-style programming patterns, where more and more code will use modern abstractions, will use not just string classes, but templatized abstractions and genericized abstractions and concepts and these higher level abstractions. So we'll see a kind of seamless progress up through the abstraction pile. And while pointers will still underlie that, we'll be able to do much better checking and much better analysis, and maybe beyond even checking, maybe we can one day get to the point where you can use pointers, but we can know for sure that those things are safe if you follow a certain restrictive set of rules. You know, there are people inside Microsoft who've worked on projects like this before. Microsoft bought a company called Calusa a long time ago that did some work in this area a long time ago, and some of those people went on to produce the .NET runtime. But the notion that you can maybe take C and make it a bit safer, and maybe a lot safer, by following a certain subset of the rules and still basically retaining the expressive power of C and C++, still retaining the flexibility, is a very interesting one that I think people are really going to be exploring.
Sure.
And the great thing that the C and C++ community are contributing is in the evolution of the libraries. We now have in Boost and a bunch of other library communities people producing new generations of libraries that are sufficiently well abstracted and sufficiently powerful that you no longer need to dig down to the pointer level a lot of the time. Often that even if a pointer is being used somewhere in your program, you're not seeing with that, you're not playing with that, so you don't have the opportunity to make the kinds of mistakes that traditionally were very easy to make in C code. So we've really just raised the abstraction, and I say we, not meaning we Microsoft, but we the C++ community as a whole, and a lot of smart people, much smarter than I am, working in a lot of different venues, are just raising that abstraction level, which is really powerful.
So, so the C++ community, just to be clear, is still very vibrant and very large. How has the reaction been to the advent of managed code? Not that Java's been around for a while, and other languages that have runtimes. What's the reaction there, just out of curiosity?
So I think when Java first came along, a lot of people in C++ felt, certainly I remember personally feeling, wow, this seems a little bit like the Emperor's New Clothes. We can do a lot of those things. Why are people so excited about that thing just because it's named after a coffee brand? You know, that doesn't seem like that's really so exciting. But I think as time went on, it became really clear when you talk to people who were really excited about Java, that there was something there. There was some real potential productivity wins and some safety wins and scenarios that you could solve that way. And of course, this is what brought companies like Microsoft to also have a runtime environment, a managed runtime, and languages like C# and VB.NET that have that managed kind of support. And I think what has happened in the last few years in the C++ community, especially with the C++/CLI standardization effort that Microsoft worked with a lot of the C++ community members on, is that there is a real attempt to take the best that has been learned from those kinds of environments and languages and bring some of that to that community. Now, you can't right now run completely verifiably safe C++ code on the .NET runtime. But you can run C++/CLI code, which is very, very like C++ and can use a lot of the patterns and idioms. We're going to produce, my team is working on something called STL/CLR, which is a re-implementation of STL done with Dinkenware that provides an STL-type programming pattern on top of the managed runtime and completely verifiable code.
Wow.
So we think we can bring some of the programming patterns that were worked on in non-managed code to the managed code universe and kind of bridge the gap between those two universes. And this is happening in a bunch of different ways. There's a lot of people looking at, well, these are the kinds of things people are trying to do effectively with managed languages. How can we bring some of that power and that safety to C++ and to the native environment too? So I think the communities are learning from each other. The initial schism that happened when people were either one kind of person or another is kind of being replaced by a genuine interchange of ideas. And you can still find plenty of people who really think native code is the only way to go, and you can still find plenty of people who think that managed code is the only way to go. But I think as a whole, the communities are starting to interact and learn from each other and react very positively to each other. And we've been excited to be a part of both sides of that equation. You know, the nice thing I think I enjoy about being in VC is we're part of both sides of that equation. We're trying to make managed code good. We're trying to make native code good.
Absolutely. And you guys ultimately compile both of those, right?
That's right. We actually compile. Our compilation is. I'm really impressed with the people who did some of this work. I mean, I was not involved in all this work. We have, not only do we have native code for x64 and i64 as well as the x86, but also we have mix mode, which is this really fascinating hybrid where you can mix managed code and native code line to line, all in the same files, and we'll push it all together and mix it all up. And this is how we get WinForms into MFC, and this is how we get a traditional C and C++ code compiled to IL code on the managed runtime, but just running there. And then we have completely verifiable safe code that is IL code, has all the verifiability of CLR code, but really reads like C++ code. It has destructors, it has templates, has deterministic finalization, has all the things you would expect out of C++ code, as well as having all those managed things you expect to. And that's a really interesting batch of different hybrids.
Excellent. Now, do you think so? Is it always just going to be C++, or is there maybe a new language coming down the line? And
C triple plus.
C triple plus. I mean, what would it be? Would it be C triple plus?
I know that there are people designing new languages still. I read recently online about a language called D, for example, which is, I guess, another way to go after C++ in terms of language names. I don't know much about D. Yeah. I think what's happened in the C++ community is instead of going to new languages, there's a lot of really smart people out there engaged in evolving to the next generation of C++. So if you look at what's in C++ Technical Report 1 and 2, the next iterations of the standards, there is so much fascinating and good thought there, and so much work in the standards committee on really innovative stuff happening, that the need for a next language in the C++ evolution has been somewhat supplanted by a really innovative and really creative community of people bringing forward C++ incrementally. But I think, there's always room for new languages. 5 years ago, I'd never heard of something called Python. I don't know when Python was come up with, but I know that we've just recently done IronPython and a lot of interesting stuff in the Python world. And new languages come up all the time that I think catch people's attention. But I think C++ is really evolving on its own right now.
Excellent. And as STL and MFC, I mean, I'm happy to hear about MFC because there was a rumor, at least on Channel 9, about a year ago, that MFC was dead. And we tried to figure out, well, that's not true, and then read some articles and blog posts, etc. And it's good to hear that absolutely is not the case.
It's absolutely not the case. So I personally have been fixing bugs in MFC and working on features in MFC and designs in MFC for several years. There has been an MFC team of as large a size as Microsoft has almost ever had in MFC for several years now. So we are actively working on MFC. In fact, if there's a person listening to me right now who is an MFC expert who'd like to come work for me, I'm hiring. I need to hire another MFC person. So if you really love MFC, you want to come work for me, definitely, I'd love to hear from you. I think the interesting thing about MFC is, with the push to manage code, we initially focused on getting that work. So this is more of a matter of focus. We spent some time on something else, but MFC was still there. And sure, maybe some people thought that in 3 years' time, C# would be everything, and C++ would go away, and all these things would happen. But I think what's happened is what you could have always expected to happen, what I certainly expected to happen, is that customers have tons of apps out there. They're very valuable apps. They're written in a certain kind of source code. And we have to preserve that investment and improve that investment. Mm-hmm. Adding WinForms to MFC is just the first step in a sequence of improvements to make sure that customers who've invested in this code have their investment preserved and brought forward to Windows Vista and to the WinFX platform and moved forward. And this is brought forward whether or not they want to take on managed code. We're going to help them integrate with WinForms. We're going to help them integrate with Avalon, hopefully. But we're also going to help them integrate with straight native code. There's a nice internal website at Microsoft with the list of new Win32 APIs existing in Windows Vista. And last time I looked at it, the count on that list was 7,124. And that includes everything. That includes all the DirectX stuff. It includes lots of different stuff. And most of that stuff wouldn't apply to MFC. But even so, there's a lot of stuff going on in Windows Vista right at the Win32 API level. And MFC is committed to being there and helping that stuff be better.
Excellent.
So that's what my team is working on planning right now, is how much of that stuff we can fit into our next version and how we can help those customers. So
beautiful. Well, thank you for your time.
Okay. Thank you.
Definitely get rid of one of those monitors, man.
Yeah, my fiance, when she first saw I had 2 monitors at home, she said to me, "Why would you want to have 2 monitors? I don't see the point in that." And then about a year later, she said, "I really like this 2-monitor thing." So you kind of do get addicted to it.
Totally.
But I probably do need to. It's getting hot in here. It's warmer in here than I probably need to lose 1 monitor at
You
least.
just get a wall, one big monitor for your wall.
But then I'd have to sit sideways, otherwise they'd be too much out of my line of sight.
Excellent. So before we go, though, I mean, this is Channel 9, and we are, we're as interested in the people as we are in the technology, obviously.
Uh-huh.
So, how long have you been at Microsoft, and where did you start? I mean, have you always been a C++ guy, or what?
Not really. So I joined Microsoft just over 10 years ago now. I had my 10th anniversary a few months ago, and I initially I actually came here to work on C++ because I loved Visual C++ 2, and I thought I should join that team when I applied. I lived in England, I applied for a job in America, I came to work on C++, but I ended up on the VC IDE team, which put me on the team that produced MS-DEV, VC5, and then we started this project to create the new shell, the new IDE, the DevEnv IDE that is now the standard shell. And I worked a bit on that project, and and then I moved on to work on something called Visual Studio Analyzer, which was a rather interesting graphical debugging technology for COM-based applications, essentially. That was kind of a lot of fun. I then spent several years on source control and team development, so you can see there's a theme here. I've always been in developer tools. I've always been kind of helping developers. That's been my thing since I've been at Microsoft. I have interest in working on other things at some distant point in the future, but developer tools is a lot of fun. And so I worked on team development, how to improve source control, how to improve source control integration in the IDE. And then about, I guess it's almost 5 years ago now, it's 4.5 years ago, I came back to VC to run the libraries team. And it's been an interesting journey in DevDiv. I think that the nice thing about the C++ customer is, of course, I write C++ code still today. I fix bugs in our product as well as leading my team. So, they're people a bit like me. There's some level of empathy that we have because those are people very like ourselves. But I think they're also very demanding people. And that's what satisfies me the most is we have lots of good competition out there, lots of different products in this space that are very, very strong, and lots of customers who know what they want and are not afraid to say so. And that provides us with a really stimulating environment to work in. So it's been 10 good years at Microsoft, I have to say. And aside from an increase in my number of monitors, it's really been worth the time. This is a lovely area to live in. I mean, I came from England. I love London. I really really miss London. But I also really would, if I left Seattle now, I'd really miss Seattle.
Sure. Well, you got similar weather patterns, so at least you get that, huh?
It's absolutely true. It's very similar weather-wise. Although it's really interesting I took my fiancée to London last year for the first time, and I showed her a graph of rainfall in London and in Seattle.
Okay.
And in Seattle, the rainfall graph is basically a U. It rains a lot in the winter and almost nothing in the summer.
Okay.
The English rainfall graph is much more flat. Essentially, any day of the year, there's about a 1 in 3 chance it'll rain, or something like that, or 1 in 2. I don't know what the numbers are, but so it's a little bit of a different chance. We had really good weather when we were in London. She loved England, so that was really great. So we had a good time.
Outstanding.
Yeah.
Well, I mean, it's great to see how far C++ has come. I mean, with 2005, you guys have done some tremendous work.
We're really excited.
And there's a lot of people out there I know on Channel 9 that are very interested in more C++ content.
Well, we'll be glad to talk about other stuff. Have anyone who's listening send in some suggestions. What do you want us to talk about? I'll be glad to do this again. It's
fantastic.
Interesting. So
maybe we'll do a little going deep into some of the core libraries and see how you guys implemented them.
Super.
But great to meet you, Mark.
Good to meet you. Thanks very much.
I'll talk to you later.